Let's see how to create and edit deflection groups, as well as define the limiting deflection in CYPE 3D. These options are available from the bar menu at the top of the interface. First, we click on Create Deflection Groups. A deflection group is a group of aligned bars that are processed together in the calculation of the deflection, even if there are intermediate nodes. During the creation of the deflection groups, a text appears on the bars indicating the deflection group to which they belong, as well as the deflection type, in brackets, in each of the two local planes of the section. By default, each individual bar itself constitutes a group of secant deflections. If desired, several aligned bars can be grouped together for the joint analysis of the deflection. To do this, we left-click on the initial node and then on the final node of the group of aligned bars. Next, the deflection group window appears, where we select the deflection type for each one of the two local XY and XZ planes of the section. This may be of the secant, tangent to node 1 or tangent to node 2 type. The secant deflection is defined as the distance between the deformed shape and straight line joining the two endpoints of the deformed shape. The tangent deflection, on the other hand, is the distance between the deformed shape and the tangent straight line to the deformed shape at one of its endpoints. For more information on the calculation of the deflection, we can click on the Show Detailed Information relative to the use of this dialog box button in the top right-hand corner that allows us to consult the help provided by the program. Normally, we will use the secant deflection for internal spans from column to column, and the tangent deflection in overhang or drifted columns. Once we accept, the program will create the deflection group among the selected nodes. The following option in the menu is Edit Deflection Groups, that allows us to edit the deflection type of the groups once they have been created. When we hover the mouse pointer over each deflection group, a dialog box appears on screen showing the information entered. Furthermore, the model displays nodes 1 and 2 to which it refers. We select the groups by clicking on them one by one or using the crossing method. Then we confirm our selection by right-clicking the mouse. The deflection group window appears again, where we can change the deflection type selected in each of the local planes of the section. Lastly, with limiting deflection, we configure the deflection limits in each one of the deflection groups. After selecting the groups, we right-click the mouse to access the configuration window. To facilitate the identification of the local planes of the section, we have a diagram of the local coordinate axes, using the same colour coding as in the model, which is shown at the top. After this, we can activate the different checkboxes to define the values for absolute maximum deflection, absolute active deflection, relative maximum deflection, and relative active deflection in both planes. Absolute deflection limits are entered in the units of measurement defined in the project, while relative deflection limits are specified as a given fraction of the L reference lengths. The maximum deflection refers to the maximum value of the deflection in the indicated plane for all displacement combinations. On the other hand, the active deflection is defined as the difference between the maximum and minimum deflection. As before, we can use the Show Detailed Information relative to the use of this dialog box button to consult the help provided by the program regarding the calculation of the aforementioned values. Once we accept, the applied values of limiting deflection are displayed over the bars in the model and in the information box that appears when hovering the mouse pointer over them. Then, from the Analysis menu, we can check the elements to verify whether or not they comply with the limiting deflection values entered.